Hello friends, welcome to my channel. Today in this video we will understand one of the LeetCode problem. The problem is find the squares of a sorted array. So let's understand what is the problem statement. So question says we are given an integer array and this array is sorted in non-decreasing order. We have to return an array which has the square of each number of that given array, and this output array is sorted in non-decreasing order. So let's understand with the help of example. Suppose you are given this array and this array is sorted. So you want this output. So here if you see, this 0 is actually the square of this, that is it is 0 square. This one is square of -1, 9 is square of 3, and this 16 is square of -4. So square of -4 will be a positive number, that is 16, and this 100 is square of 10, that is 10 square equal to 100. And all these elements in this output array, they are also sorted in non-decreasing order. Now your input can be this way also. So here -3 and 3 both will give me 9 and 9 as the square. So the square of a negative number is also a positive number. So here all these numbers are also in the non-decreasing order. So this 4 is the square of this 2, this 9 is the square of -3, this 9 is the square of this 3, and -7 will give me 49, and 11 will give me 121. Now your input can have all the numbers as negative only. So here -7, -3, these are sorted in the non-decreasing order, and this 9 is the square of -3 and 49 is the square of -7, and this output is sorted. So again you can have all the positive element. So here 16 is the square of 4 and this 49 is the square of this 7. So I hope you have understood the problem. The problem is you are given an integer array and the output should be the square of each element, and all the element in the output array, they should also be sorted in the non-decreasing order. And you can have mix of 0, positive and negative element in the input array. So let's understand the solution for this question. So let's take this example. So this is our array and we want this output after squaring and the sorted array. So what is the brute force approach or the naive approach that can come to your mind? So the brute force approach can be like we can find the square of each element of this array while scanning this array from left to right. So let's say we square each element. So we will get this array. So -7 square will give me 49. So this is -7 of square 49. Again -4 of square will be 16. The square of -1 will be 1. 0 will give me 0, and square of 3 will be 9. Square of 10, 100, and square of 11 will be 121. But this array is not equal to this array. That means this cannot be my output because I want this output, and this output is sorted and this output is not sorted. So what I can do is I can just sort this array. So after sorting this array, I will get this array, and this array is sorted in non-decreasing order. Now let's say we have all the element in our input array as negative. So suppose these are the element -8, -4 and -3. So if we apply this brute force approach, will it work? So let's see. So square of -8 will be 64. Square of -4 it will be 16, and square of -3 will be 9. So again this array is not sorted. So if we sort this, then we will get 9, 16 and 64. So yes, our approach is working. So this is my sorted output array. This is in non-decreasing order. And suppose all the elements are positive only. So let's say we have 3, 10 and 11 in our input array. So if we square them, then we will get 900 and 121. And these are sorted, but if we apply sorting again, then also we will get 900, 121, which is again a sorted output array. So we saw that our brute force approach is working in all the cases. So what is the time complexity of this approach? So we first find the square of each element of this given array. That means we scan the array from first element to the last element. So this step will take O of n time. Now to sort, we can apply, let's say, merge sort. So in that case, it will have n log n complexity. And let's say if we apply quick sort, then it will be of O of n square in worst case. So in that sense, we can say time complexity will be O of n plus O of n log n if we are applying merge sort. So total will be O of n log n, and if we are applying O of n square, then total complexity will be of On plus O of n square, that is O of n square. And what is the space complexity of this approach? So let's say we are just squaring all the element of this given array and we are not taking extra array, and then we are sorting this given array only. So in that case, we are saying it have O1 complexity, and we are also using, let's say, quick sort, in which we are not taking any extra array. So in that case, it will be O of 1. But if we are taking the extra array to store our output, then in that case, it will have O of n complexity. Or let's say we are using the merge sort algorithm. So in that case, it will have a temporary array which will be used by merge sort. So in that case also, it will have O of n complexity. So now the question is, can we do better in terms of time complexity or the space complexity? So let's see. Now, as you know, in the question, we are given the array which is actually sorted. So that means this is the smallest element, this is the next bigger element, this is the next bigger element, and so on. This is the biggest element. Now, if you see in this question, this is the first positive element, and these all element 1, 3, 7. If you see, just by removing these minus sign, then these will be 1, 3, 7. So 1, 3, 7 are sorted from this side to this side, and this 3, 10, 11, these are actually sorted from this side to this side. And next thing that you know is the square of a negative number is also a positive number. That means if you square minus 3 or if you square 3, both will give me 9. That is a positive element. So now let's understand this approach with all these information. So this solution is actually like merging two sorted array. So this 1, 3, 7 are seen from this side to this side, and this 3, 10, 11 is the another sorted array, and we are seeing this from this side to this side. So we will actually merge these elements, and during merging we will be finding the square. How we will be doing? So what I will be doing is, so after finding the first positive element in this given input array, I will set, okay, this 0 is the first positive element. Let's put a left pointer here and right pointer at here. So left will be pointing to the negative element and right will be pointing to the first positive element. So what I will be doing is, I will be comparing the absolute value of the negative element with the positive element. So the absolute value of -1 is 1 and the value of 0 is, that means 0. So I am comparing 1 with 0. Whichever is lesser, I will find the square of that element. So here 1 is greater than 0. That means this is lesser. So I will find the square of 0. So the square of 0 has to be stored somewhere. So here I will take another output array. That is, I will use the extra array, and here I will be storing the square of 0. So this will be 0. The square of 0 is 0. Now I am done with this number. So what I will be doing is, I will be shifting this right to here. So this is my new right. Now I will be comparing the absolute value of this negative element with this right element. So 1 is greater than 3 or lesser than 3. You will say 1 is lesser. So now I will be finding the square of this complete -1. So the square of -1 is 1. So now my next element is 1. Now we are done with this element. So we will come to this -3. So we are now checking -3 with this 3. So here if you see, magnitude wise, whichever is lesser, we will finding the square of that element. But here both are equal. So we have to find the square of each element. That is, we will find the square of -3. We will say square of -3 is 9. And then we will be shifting this left to this -7. And here we will finding the square of this 3 also. So the square of 3 is 9. Again, we shift this here. Now we will compare absolute value of -7 with 10. So here absolute value of -7 is 7. 7 is less than 10. So find the square of -7. So that will be 49. And now left will be decremented. So here left is now pointing to -1. Now as soon as left become -1, that is, it crossed the boundary, or right is equal to n, that is it also crosses the boundary, then we will stop this process and we will see what all remaining elements are there. So here 10 and 11 are left. So what we will do is we will find the square of all these elements as such. That is, we will scan this side 10 to 11 and we will find the square of 10. So it will be 100. Then square of 11, it will be 121. And now we are done. So we will stop here. So if in the case there are element in the left part, then we will just find the square of the left part. So only element in one of the part will be remaining, either in the left part or in the right part. So accordingly, we can find the square of those elements. So this is our final output. So this array is actually sorted and it has all the square of this given array elements. So this output and this output is actually same. So this is the algorithm that we have discussed actually, that I have written for you. So what we have done is we have find the index of the first positive element. So this is the example again that I have written for you, and these are the indexes of all these elements. So here 0 is the first positive element. So this index is actually p as per our algorithm, and we have said left equal to p minus 1. So this is actually left and this will be our right equal to p. So I have denoted left with L and right with R here. Now here we are running a loop till left is greater than equal to 0 and right is less than n. So what we are doing is we are comparing the left and right, and whichever element is lesser, we are finding the square of that element and storing in the another input array. And after all these things, whichever part of the given array, that is left part or the right part, is remaining, we are finding the square of those elements and we are just appending in the given output array, and after that we are returning the output array. So here in this loop, if you see, we are comparing the absolute value of the left part, that is we are taking the absolute value of the negative part. So we are just checking, okay, minus 1 is less than 0, the absolute value of this will be 1, so 1 is not less than 0. So here we will come and we will just find the square of the right element, that is 0. The square of 0 will be 0. So again right plus plus, so right will come here, and if we compare here, whichever element is lesser, so 1 is lesser, that is left part, so we will find the square of the left part. So we will find the square and it will be 1. Now left will be decremented and left will come to this point. Again left is greater than equal to 0, so we will say, okay, this 3, that is absolute value of minus 3, is lesser than or greater than? No, this is not lesser or greater than, it is equal. So we will come to this part and we will find the square of left, right, and we will decrement and increment accordingly. So this will give me 9 and this right will give me 9. So this is over, and we come to this left part and we come to this right part. Again both are in the limit, so we will check 7 and 10. So 7 is lesser, we will say 49, and again we will decrement this L. So L will become minus 1. Now left is not greater than 0, so we will come out of the loop, and here we will find the square of the left side element or the right side. So if we see, this is our right array and this was actually left array. So here if we see, the left part of the array is not containing any element, only the right array is containing the element. So we will find the square of this 10 to 11. So it will be 100 and 11 will give me 121, and then I will be done. We will be returning this output array. So we have actually merged this part and this part including 0, and during merging we have find the square of the array. So what is the time complexity of this approach? So first we have find the index of the first positive element, that is we have scanned this whole complete array and we find this 0. So this will take O of n time, and then we are scanning all the element only once, and then in this while loop we are scanning each and every element only once. So after the ending of this while loop, we are just finding the square of the remaining element. So essentially this whole while loop and this append part will take O of n time. So that means O of n plus O of n will give me time complexity as O of n. And what is the space complexity? So space complexity will be O of n. Why? Because we are taking the extra output array to store our answer. So actually we have traversed the given input array 2 times in this approach. First to find the index of the positive element, and then we are merging the left part and the right part, and when we are comparing, then we are finding the square of the each element of the array. So let's see the another approach in which we will traverse the whole complete array 3 times, but the space complexity and time complexity will remain same. Now before moving further, I just want to tell you one thing, that here we have used if, else if and else. What we can do is we can just write if and else, that is whenever the element are equal, we can just say else part and we can just write this given condition. We need not to write this part. Then also the program will work fine, and you can just see by running in one of the example or this given example also. So this will also work fine, or the other one, that is if and else and then this part, that will also work fine. So now let's move to the another approach. So as you have seen in the second approach, we use the left and right pointers. Here we will also use the left and right pointer, but I will use the left pointer from this point and right pointer will be set at this point. And what I will do is I will scan this whole array from this side and this side also. That is, this technique is similar to 2-pointer technique. So what I will be doing is I will be scanning this whole array and I will be comparing this left element with the right element, and whichever element is greater, I will be finding the square of that element first, and I will be storing the result in this output array. But the question is, where should I store that output square? That is, I should store this output square from left to right or right to left. So I will be storing the square of each element that I will be getting from this array from right to left side. And why we will be storing our answer from right to left, that will be more clear when we will understand this approach. So what I will be doing is, this is my left and this is my right, and this array is actually sorted. So I will be checking the absolute value of -7 with this 12, that is absolute value of left element with the right element will be compared. So we will say, okay, this 7 is greater than 12. No, it is lesser. So 12 is greater. So I will be finding the square of this 12, that is 144. So square of 12 is 144 and I will be storing here. So this output array is actually equal to the size of the input array. So that's why I'm storing the square of 12 here at the last index. Now this element is done. So I will be decrementing this right. So my right will be coming to the 6th place. Now again I will be comparing whichever element is greater. So out of -7 and 11, the absolute value of -7 is 7. So this 7 is not greater than 11. 11 is greater. So I will be saying square of 11 will be 121 and storing here. Again moving to this part. Now this absolute value with this 10. So this 10 is greater. So I will be saying this is 100. The square of 10 will be 100. Again moving to this point. Now out of absolute value of -7 with 3, this 7 is greater than 3. So that means I will be finding the square of this -7. So this -7 square will give me 49. So this 49 will be stored here, and now left will be incremented. So left will come to this point. So left will be coming here. Now we will compare the absolute value of -3 with this 3. So here these both are equal. Absolute value of -3 will be 3 and 3 is equal to 3. So what I did in the approach number 2, there I find the square of this element also and this element also, and I stored here and I decremented left and right. But in approach number 3, if we do this thing, then it will not work in some of the cases, and that I will tell you later. So what I will be doing here, I will be comparing left and right. So here 3 is not greater than 3. So what I will be doing is I will be just finding the square of the right element. So if left is not greater, I will find the square of the right element. So square of 3 will be 3 of square will be 9, and I will be decrementing here. Now out of this absolute value and this 0, who is greater? We will say this is greater. So I will be saying here the square of minus 3 will be 9. So decrementing this and L will come here. Now I will be comparing minus 1 with 0. Absolute value of minus 1 is 1. 1 is greater than 0. So I will be finding the square of this left element. So square of minus 1 will be 1. So I find the square of this one. Now next my left will go to this point. So here left is greater than right. So I will say no. So what I will be doing is I will be just saying find the square of the right element. So right element is 0. So the square of 0 will be 0. So this is our output array which contains the square of each element of this given array, and all these elements are sorted. So that means we have got our desired output. So this is the algorithm that we have discussed. So here what we have done is we have set left equal to 0, right equal to n minus 1, and till left is less than equal to right, we will run this for loop, and we are incrementing left and we are decrementing the right. So we are comparing the absolute value of left with the right, and whichever element is greater, we are finding the square of that element and storing in the output array. So if you see here, we have set k equal to n minus 1. So k is starting from the last index, and we are decrementing that k index of this given input, and we are decrementing the index k of this output array. So if left is greater, we are finding the square of left. If right is greater, we are finding the square of the right element. Correct? And if both elements are equal, then also we are finding the square of the right element. And when the for loop gets over, then we are just returning the output array. So here the time complexity, if you see, we are scanning the whole complete array just once from left to right. So it will be O of n, and only one traversal is needed. And what will be the scarce complexity? It will be of O of n. Why? Because we have used the extra output array to store our output. Now let's consider a case where we have only one element in the array. So let's say we have an array having only element 4, having at the index at 0. So we are saying left and right will be pointing to this part only, because my n is 1 in this case, and right will be 1 minus 1, 0. So left and right are pointing here. So according to this case, if left will not be greater than this, then I will be just coming to the else. That means this is saying if left is lesser than right or left is equal to right. So lesser and equal case are handled here. So now if you see this a of left is greater than right, that means a of 0 is greater than a of 0, and the absolute value of a of left will be 4 only. So 4 is greater than 4 is false. So I will be coming to else part. So here we are just finding the square of the right element. So a of right, that is a of 0 into a of 0 will be 16, and I am storing this into the output array. Output array is also having the size 1. So here in the output array, I will be storing 16, and now I will be going and I will be incrementing left, decrementing right. So left will be pointing to your 1 and right is decremented, so right is pointing to minus 1. And now this loop will be false, so we will come out of this loop and we will be just returning this output array, that is 16. So our approach is working fine. Now what will happen if we handle the case of equal to separately? So what does it mean? So here I have rewritten the approach number 3, and this approach is similar to the approach 2. So what I have added this part. So what I have done is left is greater than this, then I am finding the square of the left. If left is lesser than this, then I am finding the square of the right element. But if left and right both are equal, then as I did in the approach 2, I am finding the square of the left and right, and then I'm incrementing left and right something. Clear? So if we run this here, then we will get the wrong answer. Let's see. So my left and right will be pointing at the 0th element, and here left and right element are actually same. So this will be false, this will again be false. We will come to this else part, and here we are finding 2 times the square of this a0. So a of left and a of right are actually a of 0 and a of 0. So a of 0 into a of 0 will be 16. Again we are finding the A of right into A of right. So it will again be A of 16. So again left and right will cross each other and this loop will be false. And we will be returning this output array. So here the 16 has come 2 times, but we want just 116. So this code will not work in some of the cases. So what we have to do is we have to just handle the case of lesser than equal in else part only. We need not to write this else part. I think you have understood the solution. Now one thing I want to tell you is instead of comparing the absolute value of A of left with the A of right, you can just say if square of the left element is greater than square of the right element, then also it will work fine. And why it will work? Because when you will be comparing, let's say -1 and 0, and you are saying the square of this element, it will be 1, and square of 0, it will be 0. So here 1 is greater than 0, that is also okay. And if we just say okay, absolute value of -1, that is 1, 1 is greater than 0, that will be also okay. So same thing you can do in the approach number 2 also. So let's see the code for this. So here is our question, finding the square of the sorted array, and this code is in the C++. So here I have find the size of the array, so it is stored in the n, and now I have initialized output vector which is equal to the size of this given input array, that is n, and then we have taken index k that will be helping in storing our answer in the output array, and it is starting from the n-1 position, that is from right side. Now we have taken this for loop, and here we have just written that code. If absolute value of left is greater than right, then we are finding the left square, otherwise we are finding the right square, and we are incrementing and decrementing the right accordingly. So at last we are returning this output array. So let's submit this code and see. So yes, our solution is getting accepted. Now let's see the code in Java. So this was our question, finding the square of a sorted array, and this is the code. So first we are finding the size of the given input array, then we are taking a output array equal to the size of the given input array. We have taken a variable k which is equal to n-1, so it will be helping us to store our answer in this output array. Now we are taking this for loop, left is 0 and right is equal to n-1. So we are comparing mesh.abs left and right element. So whichever element is greater, so let's say left is greater, we are finding the square of the left element storing in the output array and incrementing the left. And if left is not greater, then we are just finding the square of the right element storing in our output array, and then we are decrementing the k, and we are also decrementing the right pointer. So after this loop gets over, we are just returning the output array. So let's submit this code, and yes, our solution is getting accepted. So that's now for this video, and if you have any comment, query or suggestion, please put down into the comment box, and if you have liked the video, please subscribe the channel. See you in the next video. Till then, goodbye.